Lesson 42, the derivative of a quotient, the quotient rule. It is a little more complicated. So what do we already know? We already know the product rule, right? So if you have two terms, so to speak, that are multiplied together, you have to do the product rule. And how does the product rule work? Okay, so I usually say derivative of the first, keep the second, plus keep the first, derivative of the second, right? And you can reverse that either way. Okay, so that's our product rule. Quotient rule, okay, so when we have a division problem, how do we take the derivative? Now, I have heard there are some calculus teachers that never teach the quotient rule. They only teach the product rule. Now, I don't know, maybe you guys would prefer that, but that means in order to do this, as you would have to change these to products. So like you would have to take that 2x plus 3 out of the denominator and say it's 2x plus 3 to the negative 1 power. That's how they, so they teach that everything can be turned into a product. Whatever's in the denominator can be brought into the numerator, and you don't have to use the quotient rule. I think that's great and grand on some easy problems, but I think it would get unnecessarily messy. So, personal opinion. Okay, did you guys look at the quotient rule? This is talking about what we do when we're taking the derivative of a quotient. So, a quotient being f of x divided by g of x. Now, notice f prime of x times g of x minus g prime of x times f of x all over g of x quantity squared. So let's put that into terms that you guys are going to use. F prime of x. So derivative of the top times the bottom, or derivative of the numerator times the denominator as is. Notice since it's a quotient rule, it's a minus. And now reverse it. Derivative of the denominator times the numerator as is. All over the denominator squared. Now, good thing to note, can we just randomly flip things around in the top? Not like we could with the product rule. Absolutely, just because you want to, but doesn't mean you can legitimately. When you do this, because it's subtraction, you have to be consistent. It has to be derivative of the top times the bottom minus derivative of the bottom times the top. I guess you could switch these two pieces around, but you can't flip the front and the back of the problem around. Does that make sense? Okay, so that's your quotient rule. Ready to try it? F of x equals natural log of x over 2x plus 3. Find f prime of x. Here's my start. F prime of x. Derivative of the numerator. So derivative of natural log of x is 1 over x. Derivative of the numerator times what? Times the normal denominator. So times 2x plus 3. Notice I put that 2x plus 3 in parentheses. And then it's going to be, because it's quotient rule, we use minus. And now we do just the opposite. Derivative of the denominator. So what's the derivative of 2x plus 3? 2 times the numerator as is, which was natural log of x. All over denominator squared. So 2x plus 3 quantity squared. good news, 2x plus 3 quantity squared, it is often okay to just leave it like that. Okay, there's a lot of different ways you can leave these and a lot of different ways you can simplify them. So we'll talk about some of them, but a lot of times you'll just see me leave it as 2 unless it really truly cleans up. The one thing you can do here, first of all, this 1 over x can distribute. Okay, so 1 over x can distribute. And then the other thing, though, when you distribute that 1 over x, what's going to happen? 1 over x times 2x becomes 2, which is nice. But what happens when you do 1 over x times 3? 3 over x. And officially, are we supposed to have fractions within fractions? No. Officially, you're not supposed to have fractions within fractions. A negative exponent within the fraction is just the same issue. And so, to get rid of that fraction within a fraction, the denominator of that fraction is going to be what? It's 3 over x. So there's going to be a denominator of x that needs to go. How do you get rid of a denominator of x? You multiply by x. Now, if I'm multiplying everything in the numerator by x, what does that mean? Multiply everything in the denominator by x. Okay, so can you guys handle this if I do both cleanups at once? I guess we'll find out. This may be a bad idea, I guess. Excuse me. So as I distribute, 1 over x times 2x was just going to be 2 times what else? Times this x, which makes it 2x. 1 over x times 3 was going to be 3 over x. 3 over x times x? 3. So that's a plus 3. And then it's minus 2 times ln x. Well, go ahead. Yep. Yeah, 2 times ln x is 2 ln x. Times an x in there, make it minus 2x ln x. And denominator? Yeah, it's 2x plus 3 quantity squared times x just means an x out front. So x times 2x plus 3 quantity squared. Okay. The cleanup was probably the harder part of that problem, I'm guessing. Questions before we try the next one? Or did you guys already start without me? Okay. It says, find derivative with respect to x of x cubed minus 2x plus 2 all over sine x. So here we go. What do I start with? Derivative of the top times the bottom. So what's derivative of my numerator? Okay. 3x squared minus 2 is derivative of the top times sine x, the denominator. Notice, of course, my 3x squared minus 2 is in parentheses. That's required. What sign goes next? Minus. And now what are we subtracting? What's the derivative of sine x? Cosine x. So it's just going to stay a normal minus cosine x times the numerator of x cubed minus 2x plus 2. all over sine x quantity squared, or in other words, sine squared x. Thoughts on cleaning this one up? I mean, there's technically some distributing you could do, yes. I mean, technically you could distribute the sine x into those two terms, distribute the cosine x into those two terms, but does that mean there's going to be anything you can add or subtract? No. I'm actually just going to let you leave this one if you want. There are ways to simplify it if we wanted to. But it also kind of becomes, what is your definition of simplification? Because any way you look at this one, it's not going to be very simplified. It's going to be kind of messy. So, and in fact, I usually kind of write in here off to the side that there are ways to simplify if we want to. Okay? I don't know that I really want to on this one. One thing I will comment about, sometimes something the book will do is they will split this into two fractions. Do you know what I mean here? Where sine squared goes with the first numerator, minus, and sine squared goes with the second numerator. The advantage of that sometimes is that, for instance, the sine can cancel here. Other than that, it doesn't make it a whole lot nicer. So it's still a pretty messy thing. Questions? Shall we do 3? You guys are extra quiet today, I feel like. Okay. Let y equals cosine x over e to the x plus x. Find dy dx. Take me through it. Derivative of cosine x. So derivative of the top is negative sine x. Times the denominator as is. So times e to the x plus x. So derivative of the top times the bottom. Then what? Derivative of the bottom times the top. So derivative of e to the x plus x. E to the x. Derivative of e to the x is e to the x. Derivative of x is 1. So e to the x plus 1 times cosine x. What sign went in the middle there? Minus. All over e to the x plus x quantity squared. About the only thing we could simplify if we wanted to is we could break it into two fractions and cancel like an e to the x plus x factor of the first fraction, but it doesn't make it any nicer. Okay? Okay, one more slight variation here. The directions ask us to find the differential dy of y equals x over cosine x. Do you remember working with differentials?
So we had to put dy and just multiply all the derivatives by dx.
Right. When you take the derivative of a y term, you put a dy after it. When you take the derivative of an x term, you put a dx after it. Whatever variable it is, right? That's essentially what we're doing here. So, derivative of y. It's 1 dy, right? Because derivative of y officially would be 1, so dy. Equals derivative of x over cosine x. Derivative of the numerator. Keep the denominator. So derivative of x, 1 dx, times cosine x. So derivative of the top times the denominator, and then what? Yeah, minus derivative of the bottom. What's derivative of cosine x? Negative sine x dx, good, times the numerator, which is x, all over cosine x quantity squared or cosine squared x. I would say doing some cleanup. There's a couple of different ways we could clean this up, and I'm going to show. First of all, 1 dx times cosine x. Yeah, the 1 doesn't need written. Dx is we tend to put at the end. So cosine x dx minus negative is going to become plus sine x times dx times x is going to best be written as x sine x dx all over cosine squared x.
Do we factor out the dx?
And that would be the one other thing we could do is to factor out the dx. So dy is going to be cosine x plus x sine x, and then in parentheses, or put that in parentheses, and then at the end factor out the dx all over cosine squared x.
We finished those before the first lunch is done.
I know, crazy, huh? Technically, if you think about, there's one other way that we could do this problem. It will only work because the y was here and these were all x's. But we could have just said dy dx, done this derivative, and then multiplied the dx over. But again, that only works because my x's and y's were already separated. Okay? Okay, questions there? Good deal.
Let me see our test.